All right, welcome back, everybody, to Chapter 10, Part 2. So in this particular chapter, we need to talk about some of the problems that happen with, uh, with internal validity, right? And trying to keep that internal validity part of the whole process. Now, if you remember, we were talking about a hypothetical example of an experiment where we had, let me try and put it over here on this side. We had, whoops, gotta get rid of that. We had the effect of stress on anxiety. All right? We manipulated stress by having 1, 2, 3 levels of the independent variable. Easy test is what we ended up with. An easy test, an impossible test, an easy test, an impossible test, easy, impossible, impossible, plus being watched. All right? So that says I have an easy test, an impossible test plus being watched. And that is going to change stress. Conversely, we are going to measure anxiety. Let's do that with an anxiety scale. All right, with an anxiety scale. Okay, so this is a simple experiment. What you have right here is a simple experiment. You've got a manipulated variable and a measured variable. We call the manipulated variable the independent variable. We call the measured variable the dependent variable. Each level of stress is a level. It is not a variable by itself, right? Easy test compared to impossible test are levels of how much stress we are causing. Now, when we talk about internal validity, we want to make sure that it's actually the stress that's causing the anxiety and not something else. We need to make sure that it's stress that causes anxiety and not something else. Now, if you remember, we were talking about something called design confounds. We need to talk about the difference between systematic variability and unsystematic variability. Systematic means systematic to your study. There's something that you did in your study that systematically changes anxiety when you don't intend to. Basically, what it's saying is you've done something that creates a confound. So let's say that when we are manipulating our independent variable, right, we've got easy, impossible, and impossible plus being watched. So whenever somebody does the easy test, we give them some candy because we want them to not be stressed, right? So when we give them the easy test, we always give them some candy. When we give them the impossible test, we just give them a cracker. When we give them impossible plus being watched, we don't give them anything because we want to make sure they're really stressed. Well, the problem is if you did that, besides manipulating stress, you are also potentially manipulating something else like blood sugar. Right? What you've done is because of the way that you did your manipulation, you actually have poor construct validity and you're manipulating something you don't intend to. And because you're manipulating that other thing, blood sugar then can be a confound, right? If somebody reads your report and says, boy, every time you gave somebody the easy test, you gave them a candy bar, and the impossible test got a cracker, and the impossible plus being watched, they got nothing. Sounds to me like you were actually manipulating how much blood sugar people were experiencing, and the blood sugar is what actually caused the anxiety, right? Less blood sugar, more anxiety. That's what happened. And you say, no, I think it was the stress. And you say, how do you know? It's confounded. What's going on is the stress manipulation is confounded with blood sugar, right? Every time you change their stress, you also change their blood sugar. It was systematic. It was something in the way that you designed it that changed it. Systematic variability is when something else varies that's not supposed to vary, right? Only stress should vary. In this entire experiment, you only want stress to vary, but you accidentally cause blood sugar to vary. A design confound is an example of systematic variability. You manipulated blood sugar when you intended to manipulate stress. And because of that, now the conclusion can be explained by blood sugar as easily as it could be explained by stress. There's a confound. Unsystematic variability is something different. Unsystematic variability has to do with other variables that are out there. So, for example, medication, right? Some of your participants might be on medication, and those medications might affect their anxiety. Now, notice that it's not the way that you did your manipulation. There's nothing in your study that changed whether or not somebody has a different medication. No, that doesn't exist. But medications could still affect anxiety. That's why it's unsystematic. It's not part of the study. It's not part of any specific system. It just exists out there. So medication could be one, family situations, etc. There's all sorts of unsystematic variability, all sorts of different variables that could be affecting your anxiety. That could be whether or not you ate breakfast. It could be whether you had a fight with your boyfriend. It could be all sorts of different things. Whether or not you feel sick today. All of those things could be affecting your anxiety. Now, they're not doing it systematically, right? It's not like each person in the easy group has a specific amount of family trauma going on. No, that's not how it's going. It's just, it just happens to be in the people. How do you control that? I can't control whether or not your family's fighting. I can't control whether or not you're on a specific medication right now. And those things could be affecting the amount of anxiety you experience in my study. Well, the way we get rid of that is through random assignment. If we randomly assign people to be in the easy group or the impossible group or the impossible plus watch group, if we randomly assign those three groups, then the amount of medication that the person is on, whether or not they're having family trauma, whether or not they ate breakfast, all of those things should be equal in the three separate groups. So if we have enough participants and we randomly assign them to each of those, then we can be sure that we have an equal amount. We can be relatively sure that we have an equal amount of all of those unsystematic variables in each of the three groups. And if all of those are equal, then they cancel each other out. They're being controlled for. They're the same for everybody. And therefore, we can say it wasn't how much medication you had that caused the anxiety, because we should have an equal amount of people with medication in the easy group, the impossible group, and the impossible plus watch group. All of those three groups should have the equal amount of medication's influence on anxiety. So it can't be medication's influence. It's got to be our manipulation. Now, the way we take care of unsystematic variability, okay, so I'm back up. Random assignment is specifically used in what kind of design? Random assignment is specifically used in independent groups design, not a within groups design, right? Because you're assigning to the different groups. You're assigning people to the easy group or the impossible group, etc. Okay? The way that you take care of unsystematic variability for within groups is that each person is taking all three of those levels. And so whether or not I have medication shouldn't affect the anxiety, because if I'm in the easy group, I have the same amount of medication. If I'm in the impossible group, it's me still, right? So it's the same amount of medication. It's me still. So impossible plus watch, it's still me. Instead of random assignment, what we do is we randomly assign the order that you put those in case there's any kind of an order effect, because there often is, right? But we don't need random assignment in a within groups design, because each person has their own baggage and they come with all their own unsystematic variability, and that's equal within that person. Now, selection effects. Selection effects are an indication of unsystematic variability. What that's saying is that if we select people to be in specific groups, right? If some people say, oh, well, you look like you had a bad day, so I'm going to put you in the easy test group, right? Or, oh, I'm going to put all of the people with glasses in the easy test group. That is a selection effect. And what you're saying is that the people who were selected to be in the specific groups, their characteristics are what's causing the changing anxiety. Now, what we do to get rid of that is use random assignment. You love random assignment. You love it, random assignment. Now, notice that I did not say random sampling. Random sampling is not the same as random assignment. Random sampling is how you get people to be in your study. Random assignment is once you have the people in your study, you assign them to different groups, which are different levels of the independent variable. You can do a study with convenient sampling and random assignment. Assignment and sampling are not the same thing. Assignment is how people are put into levels of the manipulation. Sampling is how you get people to be in the study at all. Okay. Besides random assignment, you can also do something called matched groups. In which case, if you're really concerned about something like people wearing glasses on the effect of anxiety, or people with certain medications, then what you can do is you can actually say, all right, I need to make sure that I have an equal number of people with glasses in the easy group as in the impossible group, right? So you can do that. We call that a matched groups design. But you should also be using random assignment because there's all sorts of variables that are unsystematic that you just can't control for otherwise. And so you try and keep things equal by making them random. All right. Within independent groups designs, that sounds confusing now that I said that. Using independent groups designs, there's different ways you can do this. So one is a post-test only, and another is a pre-test post-test. Now, the post-test has to do with when you take the measurement, right? The measurement of the dependent variable. So one option is to do a post-test only, and that's the most common, right? In which case, what you do is you either take the independent, you take the easy test or the impossible test or the impossible plus being watched, and then you take the anxiety. In a pre-test post-test, you would take the anxiety scale first, then go through the manipulation, then take the dependent variable again. Pre-test, before the manipulation, and post-test, after the manipulation as well. Now, the pre-test, post-test, you might say, oh, well, that makes sense. That sounds really nice. Well, the problem with that is that if number one, people tend to remember their answers, right? Especially if it's done within a short period of time. And so people might just answer the same way, be consistent. Another one is that if you've used random assignment, then it shouldn't matter what they had on the pretest. It shouldn't matter what their anxiety was coming in because it should be equal between the groups, right? Everybody should have an equal amount of anxiety beforehand. And then the only thing that was changed was the stress. And then the stress caused the anxiety change. So if you've done random assignment, then it shouldn't matter. You shouldn't need to do a pretest. Some people like to do a pretest just for the comparison, but you shouldn't have to.